Greetings and welcome, friends. Yesterday we were talking about the idea of bisectors, both angle and segment bisectors, and some properties that came out as a result of them. So here it says, find the indicated measure. Explain your reasoning. So here we've got point T is on a perpendicular segment to the segment QS, or a perpendicular line. It is equidistant from the endpoints of QS, and because it is equidistant from the endpoints of that segment, even if I didn't know perpendicularity here, I would actually know by the converse of the segment bisector theorem that this line is a perpendicular bisector. Yeah, sorry, perpendicular bisector. Converse of the perpendicular bisector theorem. And therefore, these two segments are congruent because R is the midpoint. It is right on the, it's bisected by RT, and therefore by def of Kong, QR is equal to 1 point trace. Let's see, here we go. This next one, XU is a perpendicular bisector of V dubs. Point U is therefore equidistant from V and W, and then by def of Kong, 9x plus 1 is going to equal 7x plus 13, which, by the way, 13 and 14 are the numbers that my children have the hardest time with learning how to count. Although the other morning, Everett woke up like before his little clock turns green and tells him he can get out of bed. And he told me that he's like, Dad, I counted to 1,000 this morning. And I'm just like, what? Like, that's crazy. He's a 5-year-old. And I kind of didn't believe him. And then, and then that evening, I'm like, all right, let's see how well you count. And he counted to like 120. And I'm like, all right, I think I believe you. So, yeah, true story. No, but it, like, proof of concept. Also, he knows the idea of, 100, 200, 300. So I think I believed him. I believed him. I don't believe you guys if you tell me that. I would have to have you take a test and then grade you on it. Sorry. Yeah. No, I don't think I'm interested in a guy counting to 100,000 in one video. Wow. What's this? Let's see. Am I even doing this right? UW. 7 times 6 and yeah, that's always one that I usually mess up. 42. What's that? 55. For the UW. More like WUOTI, you know what I'm saying? Let's see. Ooh, tell whether there's enough information to conclude that it is that P lies on a perpendicular bisector. So PN is a ray that is a bisector of this. Knowing this is kind of interesting, but meh. I don't believe I have enough to prove perpendicularity here. I would know that these two angles are congruent by base angles theorem. I'd know that these two angles are congruent by base angles theorem. They're actually all four congruent to each other. So I would know that, oh, wait a minute. No, you didn't. What? No. Guys, I was completely not thinking this was the case. But I just realized these two angles are congruent to each other, and they're also a linear pair. Two congruent angles that add up to 180. There's only one possibility, friends. It was the Joker. I mean, 90 degrees. 90 degrees. So therefore, yeah, it is a perpendicular bisector. That, guys, honestly, I thought this problem was going to be no. I was ready to say no, and then I done convinced myself. That's the best. Wow. Anyways. Okay, you could go back and rewatch the video. All right, here we are. Find the measure of Abd. So let's see. D is equidistant from the sides of this angle. All right. I think you agree. We measure distance from a point to a line perpendicular. And because it's equidistant from the sides by the converse of the angle bisector theorem, that means BD is an angle bisector, since D is on the interior of that angle as well. and therefore these two angles are congruent by def of Kong. They'll be equal in measure, and this is 20 degrees. Let's see, EG is an angle bisector by definition. These segments are perpendicular to the sides and go to point G. By angle bisector theorem, these are going to be congruent because G is going to be equidistant from the sides. And then we've got the classic little bit of algebra represent. Let's see, there we go. Another story about Everett. Well, I'm doing some algebra. Yesterday, he was in the car and he fell asleep, but he sleeps with his eyes open, like straight up like a centimeter. And it was just like super creepy. Like you can see his pupils. Like there's definitely light getting into his pupils. And this is something that my wife does as well ever since she was a kid. She sleeps with her eyes open a little bit, but not like a centimeter. And so I'm just thinking, like, his brain's got to just straight shut off any signal coming from his eyes. Otherwise, he's just, like, seeing light. Like, how do you fall asleep with your eyes open? Which I used to wonder. Yeah, can you fall asleep with your eyes open in a completely dark room? Is that the idea that you're saying? Like, if you just have, like, if it's very humid so you don't have to blink? Yeah, I have no idea. I'm guessing, I don't know. I'm guessing that would be hard. All right, here's a problem. Tell whether there's enough information in the diagram that allows you to conclude that EH bisects the following. So guys, I've got these two segments. They're congruent. Wait a minute. H is equidistant from F and G, these points. But I don't know if these are perpendicular. I have no idea what these angles are. I don't know if they're congruent to each other. So I don't know. I mean, like, of course, there's going to be some value, right, where it would be, right, where a circle, where two radii are going to intersect these two lines, these rays. But I don't know. Yeah, I don't know. I'm going to say no. We don't have enough information because I don't know those angles. I can't prove perpendicularity. If I'm not measuring the shortest distance to that line or that ray, yeah, I got nothing. We can't. No, because it's not perpendicular. Bam. That's all I'm saying about that. All right, tell whether there's enough information here. Yeah. AD is an angle bisector. These segments are perpendicular to the sides, and so by the angle bisector theorem, these two are going to be congruent, because, yeah, D is going to be equidistant from the sides. So, yes! Yes! Hooray! All right, so that's just a straight application of the theorem. Ooh, and here we go. Write an equation of a perpendicular bisector of the segment with the given endpoints. Now, I gave you guys this this grid. There is a way to do this non-graphically, and I'm going to do it the non-graphical way, but kind of verify each step along the way. So let's find the midpoint first. So let's find the midpoint, because that's like for perpendicular bisector. We'll do the bisector component first. So the midpoint of UV, I'll call, I don't know, M, and it's going to be the average of the x's, so 9 plus -3 divided by 2, comma, average of the y's, 8 plus 4 divided by 2. So that's going to be 6 over 2, comma, 12 over 2. Right, and notice I'm not using an equal sign because m is not equal to this. It's like an ordered pair, so that's the way I kind of try to write it. So m is going to equal 3, comma 6, gentlemen, please, if you'd be so kind. And if I go over 3 and up 6, notice I do in fact get this point right here as my midpoint, 3, comma 6. Ryan, you had an interesting thought as how to find this midpoint yesterday. Graphically, yeah, related to slope, right? Where he kind of said, okay, you just kind of count these boxes up and over, and then I think you kind of basically half those dimensions. Yeah, so instead of going up, It would be a pain, yeah, if it's going to give you decimal values or different things. But yeah, if you just find the rise to run from endpoint to endpoint, and then half those, you could land on it graphically. Yeah, using the midpoint formula. Yeah. Because I gave you the graph, and normally you wouldn't have the graph. And if I don't have the graph, then I would actually say this is easier. And also, like you just said, in many cases, your points might be in really weird spots that graphically maybe it isn't as helpful. So guys, that's the midpoint. The next thing I've got to do is find the slope of a perpendicular line. So instead of the midpoint formula, which I guess I can write down the midpoint formula for us, that's x1 plus x2 over 2 and y1 plus y2 over 2 ran out of room. And the slope formula, you guys might remember, is little m is equal to the change in y's over the change in the x, right? So let's do the slope. I usually make slope green. It's just the thing that I do. So y2 is 8 minus y1 is 4, and x2 is 9 minus negative 3 for x1. So 8 minus 4 is 4, and 9 plus 3 is 12. That reduces. 4 goes into both of those. 4 goes into 4 once and into 12 thrice. So I get m equals a third. So that's the slope of their line. I'll call that m1. So our line, how do I find my slope? I reciprocate and I negativize it, right? Opposite reciprocal, you flip it and change the sign. So here is our slope. And now the last thing we'll do is we'll take our slope and one of our points and plug it into point slope form. So let's write the equation. So write equation. And we could either do that in y equals mx plus b, plug in what I know, solve for the b that I don't, or point slope form, y minus y1 equals m parentheses x minus x1. I'm going to do the point slope form this time because I can. Let's see, what was the easiest point that I could use? I'm already gone here. I'm going to pick the point with the smaller numbers, so I'll use point u. So negative 3, 4. I'm going to rewrite that down here. Negative 3, comma 4. If I label that as x1, y1. And so I'm going to plug in negative 3 and 4 for x1, y1. I'll plug in negative 3 for the m. And we'll see how lovely this turns out. So y minus 4 equals negative 3 parentheses x minus a negative 3 becomes plus 3. And here's the equation in point slope form. And that's a perfectly legitimate equation. Point slope form is like beast mode. This is awesome. Like, I don't know, like if you have equations of lines when it comes to forms, like this is the thing that the Power Rangers would want to like form into, maybe. This is the form. I don't know enough about to make a reference. Sorry. I'm very sorry. That was a swing and a miss. I've disappointed everyone. Well, but the nice thing about point slope form is if you want to convert to slope intercept, you can quite easily without having to do algebra. You're just, well, actually there's one step of algebra, I lied. But it's a lot easier than solving for b. Right? We just solve for the y here. And I'm going to get y equals negative 3x minus 5. So there's two equations of the same line. Yeah. All right, well, thanks for watching, Internet friends. That's enough. Bye-bye.